This is Chapter 8, Problem 6. Here we have a block of 0.032 kilograms sliding down a frictionless track with a height of 5r to start, and then the radius of the loop that it's going to go through is 12 centimeters. The first thing we need to do is we need to find the work done as the block travels from point P to point Q. So let's do that. In order to find the work done, we're going to multiply the force times the displacement. In this case, the force done, let me put that on the board first, force times displacement. The force in this case is going to be the force of gravity, so that would be 0.032, the mass of the object, times 9.8. And now the displacement. We're starting at a height of 5r. Then we're moving to point Q, which is 1r above the ground, if you look at the diagram. So that means that the overall displacement, or distance traveled that we went to, was 4r, or just 4 multiplied by 12 centimeters. So that's going to be equal to 0.032 times 9.8 times, make sure to watch the centimeters, 0.48. And we get the work done by gravity is equal to, 0.1505 joules. Now, this is where a lot of people get into trouble. Is the work positive or negative? I would make the argument that the work is positive because gravity wanted this to happen. The block started at a higher height and moved to a lower height, which is exactly what gravity wants to do. So the work is positive. Now we're going from point P to a height of 2r from ground level, so now the displacement is going to be 3r. So the work done is going to be equal to the same force, 0.032 times 9.8, only now the displacement going from P to the top of the loop is going to be 3r. So that's going to be 0.36, 12 multiplied by 3. And we get a work done equal to 0.11 joules. And again, that work done by gravity is positive because gravity wanted this to happen. The system wanted all of this to happen. Now the second part of the problem, we're tasked with calculating some potential energy values. The first one we're going to calculate is the potential energy at P. The potential energy at P is going to be equal to mgh. That's the 0.032 multiplied by 9.8 multiplied by the height, and the height is 5r, so that's 0.6. So that means that the potential energy at P is going to be equal to 0.1882 joules. Moving on to the same thing for Q, the potential energy at Q. Now it's going to be the mass, 0.032 times 9.8 multiplied by the height at Q, which is going to be r, or 0.12. And now we get a potential energy equal to 0.038 joules. And finally, we are getting it at the top of the loop, the potential energy at the top of the loop. Now we're at a height of 2r, so the mass once again remains the same. I know we're kind of repeating all of our work here. 9.8 multiplied by 0.24. Remember, that's 2 multiplied by the radius. We're at the top of the loop, and that's going to be equal to 0.0753 joules. Okay? So those are our potential energy values. The last thing the problem asks us is what would happen to our potential energy values if we gave the block M a little bit more velocity at the start. So now it would have an initial velocity. Yes, that means that the total energy would change. But that means that the total energy would increase. You're not asked about that, you're asked about potential energy. The potential energy will not change because the potential energy deals with mgh. So it only depends on your height above the ground level, not the initial velocity. Remember, the total energy has increased, but the potential energy has not because you have not increased the height.